Assalamu alaikum 10th class. Hope so you all are fine. Beta, today we are going to start our topic, page number 46, refraction through prism. Prism is a transparent object made of optical glass with at least two smooth planes faces inclined towards each other, from which light is refracted. But this is a picture of prism. It is a triangular shape and it has two smooth surfaces, this side and this side. In case of triangular prism, like I show you picture, the emergent ray is not parallel to the incident ray. It is deviated by the prism from its original path. The incident ray PE makes an angle of original path. Like you see here, this is the incident ray PE and it's make an angle. Clear? At point E and is refracted towards the normal N as EF. Like you see here, PE, and then it is the incident ray and after that it is refracted as the EF. Clear? Here is the I incident angle and here is the R, that is the refracted angle. The refracted ray EF makes an angle R with the normal inside the prism and travels to the other face of the prism. The rays emerge out from prism at point F, making an angle E. Hence the emerging ray Fs is not parallel to the incident ray PE but is deviated by an angle D, which is called angle of deviation. Like you see here, here is the EF, that is the refracted ray, and the rays come out of the prism as Fs. This is the ray that is the coming out and it makes an angle, that is here, makes an angle E, and this angle is known as the angle of deviation, that create deviation. Clear? Because the PE and Fs are not parallel with each other, they are deviated from each other and here is the angle of deviation formed. After this we have lenses. A lens is any transparent material having two surfaces of which at least one is curved. Lenses refract light in such a way that an image of an object is formed, such as cameras, eyeglasses. Lenses of many different types are used in optical devices such as cameras, eyeglasses, microscopes, telescopes, and projectors. They also enable millions of people to see clearly and read comfortably. Now we have types of lenses. There are different types of lenses. The lens which cause incident parallel ray to converge at a point is known as convex or converging lens. The lens is thick at the center but thin at the edges. Like these are the convex lenses, you see these are the thick in center but thin at the edges. Another type of lens causes parallel rays of light to diverge from a point. This is called concave or diverging lens. Convex lenses are converging lens and concave lenses are the diverging lens. This lens is thin at the center and thick at the edges. Like this is the concave lens, and it is very thin in the center and from the edges it is thick. After that we have lens terminology. Principal axis, optical center. Principal axis is each of the two surfaces of a spherical lens is a section of a sphere. The line passing through the two centers of curvature of lens is called principal axis. And then optical center, see a point on the principal axis at the center of lens is called optical center. Like if this we make the center. This is the center, so this will be the optical center from where the principal axis forms. After this, we have principal focus and focal length. The light ray traveling parallel to the principal axis of a convex lens after refraction meet at a point on the principal axis called principal focus or focal point F. Hence, convex lens is also called converging lens. For a concave lens, the parallel rays appear to come from a point behind the lens called principal focus. The rays coming behind the lens, that is the principal focus. Hence, concave lens is also called diverging lens. Focal length, this is the distance between optical center and the principal focus. Optical center from the center of lens and the principal focus point from where the focal rays are coming. So this, the distance between these two is the focal length. 10th class beta, you have to do practice of this figure, this, and all the figures that we have done previously where the angles are formed, lights is reflected. All these figures you have to do practice, and if the question come, you have to draw these illustrations. Okay. After this, we have power of a lens. Power of a lens is defined as the reciprocal of its focal length in meters. Thus, power of lens is equal to P is equal to 1 over length in meters. Clear? The SI unit of power of lens is diopter, denoted by a symbol D, capital D, if F is expressed in meters, so that 1D, 1 diopter is equal to 1 per meter. Thus, 1 diopter is the power of a lens whose focal length is 1 meter. Because the focal length of a convex lens is positive, therefore its power is always positive. Whereas the power of a concave lens is negative, for it has negative focal length. Clear? For convex lens, the power will be positive, and for concave lens the power will be negative because their focal length are in positive or negative. Clear? After this, on next page, page number 51, there is a topic image location by lens equation. In figure 12.26, let an object OP be placed in front of a convex lens at distance P. This is the object OP. It is placed at a distance P. Clear? This is the P distance and the distance between object and the lens. A ray PR parallel to the principal axis after refraction passes through focus F, capital F. This is the parallel ray that is passes. Another ray PC meets the first ray at point P as the C and P. This is the refraction of light. Clear? If this process is repeated for other points of object, a real and inverted image OP is formed at a distance Q from the lens. Here the image formed. Here was the original object and the light rays coming. This distance was P from the lens and the object, and then the next from optical center to this P, here the PC formed, and here is the image of that object that was placed here. That is the real image or inverted image. That is the OP. And the distance of the image from the lens is the small q. Clear? Then on next page, when the size of the image formed in a lens for particular distance of object from the lens, what is the nature of image? That is whether image is real or imaginary, erect or inverted. It is formed, can be measured by using the lens formula. And lens formula, before doing this formula, we will read its definition. The relation between object and image distance from the lens in terms of the focal length of the lens is called lens formula. Its symbolic clarification is 1 over f is equal to 1 over p plus 1 over q. Clear? After this, we have sign convention for lenses, focal length positive for converging lens and negative for diverging lens. Converging lenses are convex lenses and diverging are concave lenses. After this, object distance p is positive if object is toward the left side of the lens. It is called a real object. If the image is towards the left side of lens, then the image will be real and the p, the distance, will be positive, and the p distance will be negative when the object will be on right side of the lens, and that is the virtual object. Clear? After this, image distance, first we talk about object distance, that is the p. Now we will talk about the image distance, that is q. Q is positive for a real image made on right side of the lens by real object. And if we see the image on the left side of the lens by real object, so it will be negative. Q will be negative. After this, you have to solve this example 12.15 and 12.16 for today.